Okay, we'll say this is the total. Here's our C plus I plus G plus exports minus imports for EP. Okay. We said spending is a function of income. That's what the function looks like. Okay. First pop quiz question. What's the slope of EP? Phil?
It's just the MPC.
It is the MPC. We started with the consumption function, and we just parallel shifted it up, right? So the slope of this curve, slope is MPC, and that's going to be important later. Okay? What about the vertical intercept? What's the vertical intercept? Karen? Autonomous what? It's autonomous total expenditure, but what is that? Starts with the A, little a, right? Meg? Well, it's little a plus I plus G plus exports minus imports. Okay? Think of it this way. The only contribution to the slope of EP is the MPC. What determines the position, whether it's high up or low down? Well, autonomous consumer spending and the other three things, which are also autonomous, that is independent income.
So A equals consumer spending.
Autonomous consumer spending.
Okay.
Here. Okay, again, it all comes from this. Total spending is just adding up the four parts. Total autonomous spending, adding up the four autonomous parts. Okay? The slope of the curve, adding up the four slopes. Slope is 0, slope is 0, slope is 0, MPC, right? So it's still the MPC. All right, now, the whole point of this model is to identify the equilibrium level of GDP, or Y. We call it Y on the graph. Okay? Where is equilibrium? That's what this whole model is designed to tell us. Okay? The equilibrium level of GDP is either where we are or where we're headed towards, if we're not quite in equilibrium yet. Okay? So that's important. This is the answer to the question, what determines how fast or slow the economy is going? This is the answer. We haven't revealed it, but that's where we're going with this. Okay? All right. Now, we're going to use a math trick. It's really simple math. Okay? This is the x-axis. This is the y-axis. Okay? We're thinking in math terms, not in economics. Suppose we want to graph the equation x equals y. What would that look like? Yeah.
Diagonal line right at 0.
1, 1, 2, 2, 3, 3, 0, 0. It is indeed a 45-degree line, which looks diagonal. Okay? So this is x equals y. Right? Very, very simple idea, I think. Right? Everybody got this? Now, let's think about the equilibrium condition. Okay, Okay, again, another digression. Let's go back to the second week of class. Quantity, price, supply, and demand. Okay? We were trying to figure out where is the market equilibrium. Okay? And the answer was what we called the equilibrium condition. How do we know if we're in equilibrium? On this graph. How do we know? Quantity supplied equals quantity demanded. That's the equation, if you will, that identifies the equilibrium. Okay? Now, similarly, there's an equilibrium condition that identifies this equilibrium. I'm going to tell you what it is, and then we're going to explain it. Okay, the equilibrium condition, which is essentially this point number 3, says we're in equilibrium if GDP equals total planned expenditure. That's equilibrium. Okay, I don't expect you to believe it now, but you will in a minute.
Wait, okay, we just said.
GDP equals total planned expenditure. Okay. Now, let's think about that. Suppose we wanted to graph this. Okay? Suppose that instead of X, this was GDP, and instead of Y, this was total planned expenditure. Okay? What would the equation Y equals EP look like? Sarah?
Yeah.
What would the equation Y equals EP, what would the graph look like? Over there.
I don't know.
Yes, you do.
It would look just like that.
It would be the 45-degree line.
Okay.
Y equals EP. Okay, does everybody see that? All we're saying is 1, 1, 2, 2, 3, 3. Whatever Y is, EP is the same. This 45-degree line defines where equilibrium is. Let me show you. Okay, let's draw our 45-degree line here. Y equals EP. Okay. Now,